All of you, good evening. So we have started wave optics, we have seen wavefront, we have defined ray, we have seen Young's double slit experiment. Then we have seen Christian Huygens principle. Using Christian Huygens principle, we proved law of what? Refraction. We have seen diffraction. We have seen diffraction at a single slit. Now what we are seeing? Reflection of a plane wave by a plane surface. What is our next topic? Reflection of a plane wave by a plane surface. This is our next topic. So first of all, you should draw the figure. First of all, you should draw the figure. Okay, reflection of a plane wave by a plane surface. Reflection of a plane wave AB. AB is the plane wave, or you should say wave front. Reflection of a plane wave AB by the reflecting surface Mn is a reflecting surface. AB and CE represents refracted, incident and reflected wavefront. AB incident wavefront, CE reflected wavefront. What is A dash A? A dash A incident ray. A dash A incident ray. What is AB? Incident wavefront. What is CE? Reflected wavefront. What is AE? AE is what? Reflected ray. Note here, draw the figure. Figure is very, very important. Figure വരയ്ക്കട്ടോ. ഫിഗറിൽ മനസ്സിലാക്കണം. A dash A incident ray, AE reflected ray, then CE reflected wavefront, AB incident wavefront. This angle is 90 and this is I. This is angle R. This is also angle R. Please draw the figure. What you are doing? You are proving law of reflection using Huygens principle. ഫിഗർ വരയ്ക്കട്ടോ. ഫിഗർ വരയ്ക്കും മക്കളെ. ഫിഗർ ഭയങ്കര ഇമ്പോർട്ടൻ്റ് ആണ്. ആ ഫിഗർ വരയ്ക്കലാണ് കാര്യം. ലിസൺ, you have to prove refraction and reflection using Huygens principle, but more common is the reflection question because it's a normally it fits correctly to a 3 mark problem. 3 മാർക്ക് ക്വസ്റ്റ്യൻ അല്ലെങ്കിൽ 4 മാർക്ക് 5 മാർക്ക് ക്വസ്റ്റ്യൻ ആയിട്ട് ചോദിക്കാൻ കൂടുതൽ ചാൻസ് റിഫ്ലക്ഷൻ ആണ്. കാരണം റിഫ്രാക്ഷൻ കുറച്ചുകൂടി ലെങ്തിയാ. വരച്ചെടുക്കട്ടോ. വരച്ചെടുക്കണം. വരയ്ക്കാൻ ചോദിക്കും. വിത്ത് ഫോൾഡഡ് ഹാൻഡ്സ് ഐ ആം ടെല്ലിങ് യു, ഇറ്റ്സ് എ വെരി വെരി ഇമ്പോർട്ടൻറ്റ് ക്വസ്റ്റ്യൻ. അഗെയിൻ വരയ്ക്കാനാണ് വരിക. എൻട്രൻസിന് ഇത് ചോദിക്കില്ല. വരയ്ക്കാനാണ് വരിക. തിയറി എക്സാമിന് ക്രിസ്ത്യൻ ഹൈഗൻസ് പ്രിൻസിപ്പിൾ ഭയങ്കര ഇമ്പോർട്ടൻ്റാ. Any doubt? Done? Figure വരച്ച് കഴിഞ്ഞാ? എല്ലാവരും figure വരച്ച് കഴിഞ്ഞാ? Chaithanya done. What about others? മക്കളെ ഫിഗർ ഡീറ്റെയിൽ ആയിട്ട് വരയ്ക്കണം. ഫിഗർ വരയ്ക്കാനാണ് പരീക്ഷയ്ക്ക് വരിക. ഞാൻ വെയിറ്റ് ചെയ്യുന്നത് നിങ്ങൾ ഫിഗർ വരയ്ക്കാനാണ്. ബിക്കോസ് ദിസ് ക്വസ്റ്റ്യൻ ഇസ് വെരി 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 ഇമ്പോർട്ടൻറ്റ്. ഇറ്റ്സ് എ വെരി വെരി ഇമ്പോർട്ടൻറ്റ് ക്വസ്റ്റ്യൻ. Mismaya done. Abhiraj done. All of you done. Yeah, done. Now let's see. A plane wave AB a plane wave AB incident at an angle I in a reflecting surface Mn, on a reflecting surface Mn reflecting surface, you can see what is falling. A plane wavefront, incident wavefront AB falling at an angle I on a reflecting surface Mn. Okay. If V represents the speed of wave in the medium, and if tau represents the time taken by the wavefront to advance from point B to C, then the distance BC is equal to V tau. How? Velocity equal to what? Displacement or distance by time. Distance equal to what? Velocity into time. What is the distance here? BC. What is velocity? V into time is what? Tau. So BC distance is what? BC distance equal to V tau. Any doubt? BC distance equal to V tau. In order to construct the reflected wavefront, we draw a sphere of radius V tau from point A as shown in the figure. So from point A, we draw a sphere of radius what? V tau. In order to construct the reflected wavefront, we draw a sphere of radius what? V tau from point A as shown in the figure. Let C represents represents the tangent plane drawn from the point C to the sphere. See, from A, I am drawing a sphere of radius what? V tau. From C, I am drawing a tangent. To this point E. So CE is what? Reflected wavefront, and AE is what? Reflected ray. Remember, from A, I am drawing a sphere of radius V tau. So AE is the reflected ray, and C is what? From point C, I am drawing a tangent to point E. So CE is what? Reflected wavefront. In order to construct the reflected wavefront, we draw a sphere of radius V tau from the point A as shown in the figure. Let C represent the tangent plane drawn from the point C to the sphere. Then AE equal to BC is equal to V tau. Why? Again, please remember AE. What is A? This is AE. AE is equal to what? BC. What is BC? See, AE is equal to BC. These two distances are equal. Why equal? Because velocity into time. Some students might be thinking, sir, why you have not written V1, V2? Because it is in the same medium. We are discussing about the reflection. Medium does not change. So velocity remains the same. So AE is equal to BC is equal to what? V tau. If we now consider the triangles EAC. EAC If we now consider triangles EAC and BAC, what are the two triangles? E triangle, I am drawing triangle with another color. EAC, triangle EAC, and triangle BAC. Triangle EAC and BAC. See, both the triangles have common hypotenuse and one side is also equal. Both triangles have common hypotenuse and sides are also equal. That means what? These two triangles are congruent triangles. If triangles are congruent, the inner angle should be what? Equal. That means what? Angle I is equal to angle R. If we now consider the triangles EAC and BAC, we will find that they are congruent and therefore the angles I and R as shown in the figure will be equal. Therefore, angles I and R shown in the figure will be equal. So what happens? Angles I and R shown in the figure will be what? Equal. First, note down this paragraph, then I will show the other paragraph. Any doubt? So we have proved what? BC equal to, we have proved what? BC is equal to AE is equal to VTO. And then we consider two triangles, triangle EAC and triangle BAC. So what happens? Hypotenuse are common and two sides are equal. That means what? They are congruent triangle. If triangles are congruent, the angles will be equal. That means what? Angle of incidence is equal to angle of reflection. മനസ്സിലായോ? ആ ഫിഗർ വരച്ച് രണ്ട് മൂന്ന് പാരഗ്രാഫ് ഇതാണ് ഏറ്റവും കൂടുതൽ ചോദിക്കാൻ ചാൻസ് ഉള്ള ക്വസ്റ്റ്യൻ +2 ഫിസിക്സിൽ. നോട്ട് ചെയ്യാട്ടോ. ആ രണ്ട് പാരാഗ്രാഫ് എഴുതിയെടുക്കട്ടോ മക്കളെ, അത്ര ഇമ്പോർട്ടന്റ് ആണ്. എഴുതണില്ലേ? ഇത് മനസ്സിലായ? ഇത് വളരെ ഇമ്പോർട്ടന്റ് ആണ്. ഞാൻ അത്ര ഇമ്പോർട്ടന്റ് ആയതുകൊണ്ടാണ് റിപ്പീറ്റഡ് ആയിട്ട് പറയണേ. എൻട്രൻസുകാർ ഇത് ശ്രദ്ധിക്കില്ല. ഇത് ഷുവർ ക്വസ്റ്റ്യൻ ആണ്. ഹൈഗൻസ് പ്രിൻസിപ്പിൾ, റിഫ്ലക്ഷൻ, റിഫ്രാക്ഷൻ പ്രൂഫ്. ആ രണ്ട് പാരാഗ്രാഫ് കഴിഞ്ഞ അത് കഴിഞ്ഞാൽ ഞാൻ ആ പാരാഗ്രാഫ് കാണിക്കാം. ആ രണ്ട് പാരാഗ്രാഫ് നോട്ട് ചെയ്താ. Then note down this paragraph. The Doppler effect is not required, it's a deleted topic. If we now consider the triangles EAC and BAC, we will find that they are congruent. They are congruent triangle, and therefore what should happen? The angles I and R shown in the figure should be equal. That means what? Angle of incidence is equal to what? Angle of reflection. If I and R equal means what? Angle of incidence is equal to angle of reflection. This is the law of reflection. Note ചെയ്തോ? നോട്ട് ചെയ്തില്ലേ? നെക്സ്റ്റ് topic ആണ്. Listen, we have proved Huygens principle when light ray travel from rarer to denser. Now exact opposite we have to prove. What is that? Denser to rarer. So it is called refraction at a denser medium. Refraction at a not denser, rarer medium, because light ray is traveling from rarer to what? Is it rarer to denser or denser to rarer? Refraction at rarer medium means what? Light ray traveling from denser to rarer. So this is a denser medium, first medium, and the second medium is what? Rarer medium. That means what? Light ray is traveling from denser medium to rarer medium. So what is A dash A? See, we are doing this derivation in order to make sure that our previous derivation is confirmed, or you are 100% sure about the previous derivation. Again, same point only. A dash A is what? Incident ray. A dash A, incident ray. It is incident at an angle what? Angle of incidence I. And the reflected ray is what? Not reflected, AE. AE is what? Refracted ray. How we are getting AE? From point A, we are drawing a sphere of radius what? Radius V2 tau. Why V2 tau? This is V2 tau. Why we are writing V2 tau? Because it is in the second medium. Now AB is what? Incident wavefront. From point C, we are drawing a tangent CE to the AE. So this angle will be what? 90 degree. This angle is what? R. So this will be what? 90 minus R. So this angle will be what? 180. This angle will be what? 180 minus 90 plus 90 minus R. So 180 minus 180 plus R. So this angle is what? R. So what is CE? Refracted wavefront. What is AE? AE is equal to V2 tau is what? Refracted ray. What is A dash A? Incident ray. This angle is I. Then this will be what? If this angle is I, this will be what? 90 minus I. This angle is 90. Any doubt? Makkale doubt na? Nertha varcha figure aanu. Only thing is that now light ray is traveling from what? Denser to rarer. Any doubt? Doubt na? Figure note cheyanam. Figure varikkel oruvaadu time consuming aanu, but still I am telling you draw the figure because it is a sure question. ഇത് NCERT ടെക്സ്റ്റ് ബുക്കിലുള്ള ഫിഗർ ആണ് കേട്ടോ. റിഫ്രാക്ഷൻ അറ്റ് റെയർ മീഡിയം NCERT ടെക്സ്റ്റ് ബുക്കിലുള്ള ഫിഗർ ആണേ. വരയ്ക്കണം, പഠിക്കണം. നോട്ട് ചെയ്ത് കഴിഞ്ഞോ? നോട്ട് ചെയ്തോ? ഡൺ. Now consider refraction of a plane wave. Consider, I hope you have drawn the figure. So just see the theory part. It's a repetition of the first derivation. Let's see. Consider refraction of a plane wave at a rarer medium. Consider refraction of a plane wave at a rarer medium. So what is the case? Light ray traveling from denser to rarer. Rarer medium means light ray travel from denser to rarer. So what happens? Speed of light in second medium will be greater than speed of light in first medium. Let PP dash represents a surface separating medium 1 and medium 2 as shown in the figure. Light travel from denser medium to rarer medium. We assume a plane wavefront AB propagating in the direction A dash A. A dash A is what? Incident ray on the interface at an angle I as shown in the figure. Let it tau be the time taken by the wave front to travel the distance. Then BC is equal to what? V1 tau, equation number 1. In order to determine the shape of the refracted wavefront, we draw a sphere of radius V2 tau. I hope you remember, from A, we draw a sphere of what? Radius V2 tau. From point A in the second medium. The speed of the wave in second medium is what? V2. Then what? We from this point C, we draw a tangent. So this is what? A. This is AE. From point C, we draw a tangent, CE. What is this tangent? That CE represents what? Tangent plane. Okay. Then AE is equal to what? V2 tau. Then initially BC was equal to what? V1 tau. I hope you remember that. അല്ലേ നമ്മളത് ഡിസ്കസ് ചെയ്തിട്ടല്ലോ അല്ലേ നോട്ട് ചെയ്യട്ടോ അവിടെ വരെ നോട്ട് ചെയ്യും then I will continue please note down up to that point നോട്ട് ചെയ്യണട്ടോ എഴുതണം മക്കളെ ഞാൻ വീണ്ടും പറയുന്നു ഷുവർ ക്വസ്റ്റ്യൻ ഏറ്റവും കൂടുതൽ ടൈം എടുത്തിട്ട് പഠിപ്പിക്കുന്ന ടോപ്പിക്കാണ് ഇത് ഷുവർ ക്വസ്റ്റ്യൻ ആണ് ഒരുപാട് ടൈം എടുക്കേണ്ട ഡെറിവേഷൻ കംപ്ലീറ്റ് ചെയ്യാൻ. പക്ഷെ ഇത് ചോദിക്കും. ലിസൺ, എൻ്റെ സ്കൂളിൽ ഞാനത് റിവീൽ ചെയ്യാൻ പാടുമോ? ഓക്കെ. എൻ്റെ സ്കൂളിൽ മോഡൽ എക്സാം ആണ്. ഞാനാണ് പേപ്പർ ഇടുന്നത്. സെക്കൻഡ് മോഡൽ എക്സാം, ഓൾ സെക്കൻഡ് വോളിയം പോർഷൻ. അതിൽ ഹൈഗൻസ് പ്രിൻസിപ്പിൾ 2 ക്വസ്റ്റ്യൻ ആണ്. യൂസിങ് ഹൈഗൻസ് പ്രിൻസിപ്പിൾ പ്രൂവ് ലോ ഓഫ് റിഫ്ലക്ഷൻ ആൻഡ് യൂസിങ് ഹൈഗൻസ് പ്രിൻസിപ്പിൾ പ്രൂവ് ലോ ഓഫ് റിഫ്രാക്ഷൻ. Then there is no confusion. But in some CBSE question paper, they will clearly say that using Huygens principle, prove law of refraction at a rarer medium. Then this case only you should draw. When it is a general question, we can simply draw either denser to rarer or rarer to denser. But when they say specifically refraction at a rarer medium, then you have to draw the case denser to rarer. Noted? I'm just scrolling it. In order to determine the shape of the refracted waveform, we draw a sphere of radius v2 tau from point A in the second medium. The speed of wave in the second medium is v2. Let C represents a tangent plane drawn from the point C on the sphere. Then AE is equal to what? v2 tau. AE is equal to what? AE is equal to what? v2 tau. And CE could represent the refracted wavefront. If we now consider the triangles ABC and AEC. Please note down the last 2 lines. Those who have done previous derivation, those who have by hearted understood the previous derivation can easily proceed with the derivation. Finish the last 2 lines. We are considering 2 triangles. What are they? ABC and AEC. Yeah, we readily obtain then the previous derivation, same derivations. What is that? What is that derivation? Sin I is equal to what? Sin I is equal to, okay, once again I will show you that figure. Sin I is equal to what? What is the figure? Yeah, figure it is at the back. Yeah. Sin I is equal to what? BC by, okay, but better to write here. So in order to derive sin I is equal to, what is equation? BC by opposite side by hypotenuse. So BC by AC, sin R is equal to also what? Sin r equal to AE by AC. So sin I by sin r is equal to what? Sin I by sin r is equal to BC by AC divided by AE by AC. That is equal to BC by AC into AC by AE. So AC gone. BC is equal to what? What is BC distance? V1 tau. AE is equal to what? V2 tau. So sin I by sin r is equal to what? Sin I by sin r is equal to V1 tau by V2 tau. That means sin I by sin r is equal to sin I by sin r is equal to what? V1 by V2. Sin I by sin r is equal to what? V1 by V2. Any doubt? Sin I by sin r is equal to V1 by V2. Now, continuing with the derivation, sin I by sin r equal to V1 by V2. Now, continuing with the derivation, from the above equation, above means what? From the equation sin I by sin r, we got the important relation that when r is less than I, V2 has to be what? Less than V1. That is if if r is greater than I, that is if the refracted ray bends away from normal, then the speed of light in second medium should be greater than the speed of light in first medium. If C represents the speed of light in vacuum, we know that N1 is equal to what? Refractive index of first medium is equal to what? If C represents speed of light, C represents speed of light in vacuum, then N1 is equal to what? C by V1. N2 is equal to what? C by V2. So N1 by N2 is equal to what? C by V1 divided by what? C by V2. So N1 by N2 is equal to C by V1 into V2 by C. So C gets cancelled. So N1 by N2 is equal to what? V2 by V1. So whenever I see N1 by N2, I can replace it with V2 by V1. So when I look at here, I am seeing V1 by V2. So that can be replaced with what? V2, V1 by V2 is what? N2 by N1. So that means if you cross multiply, N1 sin I is equal to what? N2 sin R. That is N1 sin I is equal to N2 sin R. N1 sin I is equal to N2 sin R means what? Which law? Snell's law. That means we have proved Snell's law for refraction. Snell's law for refraction when light ray travel from denser to rarer medium. Any doubt? Makkale, any doubt? ഡൗട്ട് ഉണ്ടോ? വാല്യുവേഷന് പോകുമ്പോഴേ പലപ്പോഴും ഞങ്ങൾ ടീച്ചേഴ്സ് ആ ഫിഗർ അവിടെ ഉണ്ടോ നോക്കും, എന്നിട്ട് ഇപ്പോൾ ഞാൻ ബോർഡിൽ എഴുതിയതുണ്ടോ നോക്കും. അല്ലാതെ ആ തിയറി ഒന്നും കുട്ടികൾ സാധാരണ എഴുതാറില്ല. ഈവൻ വിത്തൗട്ട് തിയറി ഓൾസോ, ഇഫ് യു ആർ സിംപ്ലി ഡ്രോയിങ് നീറ്റ് ഫിഗർ ആൻഡ് റൈറ്റിംഗ് ദിസ് ഇക്വേഷൻ ആൻഡ് പ്രൂവിങ് ഇൻ ദിസ് വേ, സ്റ്റിൽ യു വിൽ ഗെറ്റ് ദ ഫുൾ മാർക്ക്. മനസ്സിലായോ? ഡൗട്ട് ഉണ്ടോ? Vismaya done. What about others? Please finish it. I hope all of you have finished this. So അത് നമ്മൾ പ്രൂവ് ചെയ്തു കേട്ടോ. ശരി, ഇനി ജസ്റ്റ് ചെറിയൊരു ടോപ്പിക് ഉണ്ട്, അത്ര ഇമ്പോർട്ടൻ്റ് ഒന്നല്ല. ശരിയാ, അത് ഇത്രയാണ്. ഈ സൗണ്ട് വേവ്സ് ഓഫ് അവർ സ്പീച്ച്, sound waves of our speech has a wavelength of about what 50 centimeter to 1 meter. So we make different sounds. No, the sound waves of our speech signal has a wavelength of what 50 centimeter to 1 meter. So if it meets an obstacle of that much size, it can bend around. But what is the problem with the light? Light is having high frequency, very small wavelength. Wavelength is in the nanometer range. So if light is meeting with an obstacle of that much small size, then only light can bend around. ലൈറ്റിന് ചുമരിനെ ബെൻഡ് ചെയ്ത് അപ്പുറത്തേക്ക് കടക്കാൻ പറ്റില്ല, പക്ഷെ സൗണ്ടിന് ബെൻഡ് ചെയ്യാം. എന്താ റീസൺ? സൗണ്ട് വേവ്സ് എന്താ? സൗണ്ട് വേവ്സ് ഓഫ് അവർ സ്പീച്ച് സിഗ്നൽസ് ഹാവ് ലാർജ് വേവ് ലെങ്ത്. ഒരു ഒബ്സ്റ്റക്കിളിനെ ബെൻഡ് ചെയ്യണമെങ്കിൽ ദ കണ്ടീഷൻ ഈസ് ദാറ്റ് ദ സൈസ് ഓഫ് ദ ഒബ്സ്റ്റക്കിൾ ഷുഡ് ബി കമ്പയറബിൾ ടു ദ വേവ് ലെങ്ത് ഓഫ് ലൈറ്റ്. The sound waves or speech has a wavelength of about what 50 centimeter to 1 meter. If it meets an obstacle of this size of a few meter, it bends around it and reaches the point behind the obstacle. But when it comes across a larger obstacles of a few hundred meters, such as hillocks, most of it is reflected and is heard as an echo. But what is the problem with the light? Light can bend around obstacles of, bend around means diffraction of very small size only. I should add one more very small size only, since light is having high frequency and a very low wavelength, very small wavelength. And one more point, if a wave wants to bend around an obstacle, bend around an obstacle, the size of the wave, size of the obstacle should be comparable to wavelength of light. Should be comparable to wavelength of light. Should be comparable to wavelength of light. Light nalla, wavelength of the wave. I started with the wave, right? Wavelength of wave. So if a wave wants to bend around an obstacle, the wavelength of the wave and the size of the obstacle should be comparable. It should be almost same. Please note it down. ഇതോ ശരിയല്ലേ? ഇനി ഇതൊക്കെ ഡിലീറ്റഡ് ആണ്. ഇവിടെ ഒരു പാരാഗ്രാഫ് ഉണ്ട്. ആ പാരാഗ്രാഫ് നമുക്ക് ആവശ്യമുണ്ട്. അതായത് in interference and diffraction, the paragraph is like this. Only this paragraph is required. In interference and diffraction, light energy is redistributed only. If it reduces in one region, producing a dark fringe, it increases in another region, producing a bright fringe. There is no gain or loss of energy, which is consistent with the principle of law of conservation of energy. Principle of law of conservation of energy. See, in interference and diffraction, we are not creating energy, we are not destroying energy. Energy gets redistributed. If it reduces in one region, energy reducing means what? Destructive interference. Then it increases in another region, that is constructive interference. We are not creating energy, we are not destroying energy. Only thing is that energy gets redistributed. Energy gets what? Redistributed. Energy gets what? Redistributed. ഇത് ഡിലീറ്റഡ് ആണ് കേട്ടോ. ആ ഒരൊറ്റ പാരഗ്രാഫ് നോട്ട് ചെയ്യുക കേട്ടോ. Interference and diffraction. Only that paragraph has to be noted. Is there any pressure change? No. Pressure also remains the same. Generally, we won't consider pressure as an important parameter. Pressure also remains the same. Devika, pressure doesn't vary. Pressure remains the same. Done. Next interference condition I directly percentage square derive fringe position bright fringe dark fringe equation condition for constructive interference condition for destructive interference slit width and ratio and the problem resolving power deleted. Yeah, okay. Then there are certain questions which are application level questions. Application level questions. See the first question. Two independent monochromatic sources of light cannot produce a sustained interference pattern. Give reason. Once again, I will read the question. Two independent monochromatic sources of light cannot produce sustained interference pattern. How come this question come? Because in the interference, we know that first we use one monochromatic source of light, and then this is S1, S2. The question tells you, why can't we use two separate light rather than taking light from a single slit or light from a single monochromatic light? Why can't we eliminate this and use two separate torches here? Why can't we use separate torches here rather than using the light of a single monochromatic torch or a single monochromatic light source? Why we are not using this way? Means why we are not using this way? Why this method is wrong? Why this method of using two separate monochromatic source of light method is wrong? Yeah, I think Navneet has written the answer correctly. See, the phase difference between the light waves originating from two independent monochromatic sources will change rapidly with the time. So what is the problem? Phase difference between light waves originating from two independent monochromatic sources will change rapidly with the time. The two sources will not be coherent. What is the condition for coherent source? Same amplitude, same wavelength, same frequency, phase difference should be either 0 or constant. If you are using two separate monochromatic sources of light, phase difference will not be a constant. Phase difference varies with the time and therefore will not produce sustained interference pattern. This question is a very important question. In my 18 years of teaching experience, I have seen this question minimum 4 times. I think more than that. And 2 times in entrance also. Choose the right statement, choose the wrong statement. It's a very important question. Please note it down. Note it down, note it down. Question. If the separation between two slits decreased in Young's double slit experiment, keeping the screen position fixed, what will happen to the fringe width? What is the equation for fringe width? Beta equal to d lambda by d. Separation d between the two slits decreases. So what happens? D decreases, fringe width increases. Any doubt? നിങ്ങൾ എഴുതണില്ലേ മക്കളെ? നോട്ട് ചെയ്യുന്നില്ലേ? ഇതൊക്കെ റിപ്പീറ്റഡ് ക്വസ്റ്റ്യൻസ് ആണ് കേട്ടോ. റിപ്പീറ്റഡ് ക്വസ്റ്റ്യൻസ് ആ. ലേറ്റസ്റ്റ് CBSE you can expect these questions based on case study based question. Question number 29 and 30 are case study based question. In CBSE question paper, 29 question and 30th question will be case study based question. In those type of question you can see this. നോട്ട് ചെയ്താ? അടുത്തത് next question. How does the fringe width in Young's double slit experiment? How does the fringe width in Young's double slit experiment change when the distance of separation between slits and screen is doubled? Distance of separation between slit and screen both are doubled means what? So both will cancel. So what happens? Fringe width beta equal to d lambda by d. Distance d between slits and the screen is doubled. So only small letter d is increased. No, sorry, capital letter D is doubled. So what happens? Fringe width also becomes 2 times. Any doubt? I hope you remember what is this. This is S and these two are S1, S2 act as coherent source. This is the screen. So small letter capital letter D is the distance between coherent source and screen. So this is small letter D. Distance between coherent sources, small letter D. Distance between coherent source and screen is what? Capital letter D. So what happens? Beta equal to d lambda by d. When the distance between coherent source and screen is doubled, capital letter D becomes 2 times. So what happens to beta? Beta also becomes 2 times. Fringe width also becomes 2 times or doubled. Any doubt? And next question you should do yourself. In YDSC, generally in some question paper, Instead of writing Young's double slit experiment, they will simply use a shortcut YDSE. If the distance between two slits is halved and the distance between the slit and the screen is doubled. So instead of D, we are writing 2D. Instead of distance between the screen, you are using, instead of distance between coherent source, we are using D by 2. So what? That 2 moves to numerator, it becomes 4D lambda by D. That means what? Fringe width becomes 4 times. Any doubt? മനസ്സിലായോ? Doubt ഉണ്ടോ? Next, no interference pattern is detected when two coherent sources are infinitely close to one another. See, when coherent sources are very close to one another, see, screen distance between coherent source and screen capital letter D is fixed, wavelength of light is fixed also. So beta directly proportional to what? 1 by D. When D becomes 0, fringe width becomes what? Infinity. Sorry, that means fringe width is very large. Even a single fringe may occupy the entire screen. So what is the problem? We cannot see the interference pattern when the two coherent sources are very close to each other. This is also important, this question. See, these type of questions are application based questions that you can see especially in CBSE question papers. State also it will be there, but generally it comes in CBSE question paper. Please read it and note it. Okay. Remember, capital letter D is the distance between coherent source and screen, and small letter D is the distance between two coherent sources. A figure I should draw the figure one more time. S monochromatic source of light, S1 and S2 coherent source. The distance between coherent source, small letter D. Distance between coherent source and the screen, capital letter D. Note it, all questions note it. Important application level questions. കഴിഞ്ഞ നോട്ട് ചെയ്താ? എല്ലാ കേസും നോട്ട് ചെയ്താ? ഇനി അടുത്ത കേസ്. Why is interference pattern not detected when two coherent sources are far apart? When distance between the two coherent sources is large, like fringe width beta directly proportional to 1 by d becomes too small to be detected, the interference pattern cannot be observed. So it should not be too close and also too far. If coherent sources are too close, then interference fringe width will be what? Very large, and one fringe itself may occupy the entire screen. So you cannot see interference pattern when two coherent sources are very close to each other. And when they are far apart, then interference fringe will be very small. Fringe width will be very small. Then also you cannot see interference. In Young's double-slit experiment, light of green, yellow, and orange. Light of green, yellow, and orange are used. In this, colors are successively used. Find the fringe width for the three colors in increasing order. See, beta is equal to d lambda by d. So here d, capital letter D and small letter d are constant. So fringe width directly proportional to lambda. So which one is having high wavelength? When you write lambda in the order, Vibgyor. So which one is having high wavelength? Red. Red is there? No. Yellow, orange is there. So orange will be having greatest fringe width, which is greater than yellow is there. Yellow, fringe width of yellow, which is greater than fringe width of green. Any doubt? Fringe width is directly proportional to wavelength. So higher the wavelength, higher will be the fringe width. Doubt na? Higher the wavelength, higher will be the fringe width. Any doubt? Yeah, fringe width of orange greater than yellow, greater than green. ഇതൊക്കെ റിപ്പീറ്റഡ് ക്വസ്റ്റ്യൻസ് ആട്ടോ. ബോർഡ് എക്സാമിന് റിപ്പീറ്റഡ് ആയിട്ട് ചോദിക്കുന്ന അപ്ലിക്കേഷൻ ലെവൽ ക്വസ്റ്റ്യൻസ് ആണ്. ദീസ് ഓൾ application questions related to Young's double slit experiment, which are very, very, very important. മക്കളെ നിങ്ങളെ ക്ലാസ് ലൈക്ക് ചെയ്തോളൂ, പരമാവധി ഷെയർ ചെയ്തോളൂ, അതേപോലെ ആ ലൈക്ക് ബട്ടൺ ചെയ്തോളൂ കേട്ടോ. കാരണം നമുക്ക് പരമാവധി ആൾക്കാരിലേക്ക് ഇത് എത്തണം. അപ്പോൾ ഒന്ന് ഷെയർ ചെയ്തോളൂ കേട്ടോ. ഇറ്റ്സ് എ റിക്വസ്റ്റ് ഫ്രം മൈ സൈഡ്, പ്ലീസ് ഡു ഇറ്റ്. നമ്മൾ വിബ്ജിയോറെ എന്ത് ഓർഡറിൽ എഴുതിയാണേ? വേവ് ലെങ്ത്തിന്റെ അസെൻഡിങ് ഓർഡർ കേട്ടോ. വേവ് ലെങ്ത് അസെൻഡിങ് ഓർഡർ. വേവ് ലെങ്ത് അസെൻഡിങ് ഓർഡർ. So red is having highest lambda. highest. Lambda means what? Lowest frequency. Violet, lowest lambda, highest frequency nu. Highest frequency nu. Any doubt? മനസ്സിലായോ? മക്കളെ മനസ്സിലായ? മാഷ് സ്റ്റോപ്പ് ചെയ്യാനായിട്ട് ഇവിടെ. Okay, thank you. Next class we will be doing problems of Young's means wave optics. Next class we will be doing problems of wave optics. So thank you students. Thank you. Like here, share it.